Okay, in last class, I explained what is that valence cell, penultimate cell, anti-penultimate cell, and also we have studied valence electrons, core electrons, and electronic configuration. Okay, today our topic is writing the electronic configuration in the elements whose contains atomic number from 1 to 30. That means I want to explain the electronic configuration in the elements from 1 to 30. How we are writing, I am explaining. Today, that is our topic. So, what is that heading? Our heading is writing of electronic configuration. Writing of electronic configuration. We write down this. Writing of electronic configuration. In our elements. From atomic number Z, from atomic number 1 to 30. 1 to 30. So this is our today topic. So in order to understand and writing the electronic configuration in different elements, the range lies from atomic number range lies from 1 to 30. Okay, you want to understand this concept, we need some basic knowledge. What is that? Yesterday I explained electronic configuration. So what do you mean by electronic configuration? Electronic configuration means the arrangement of electrons in and different orbitals from lower energy to higher energy. So that is called what? Electronic configuration. So you want to write the electronic configuration. Before that, you have a idea about lower orbitals and higher orbitals. Which one orbitals are lower orbitals? Which one are higher? How can you predict the particular orbital is lower, the particular orbital is higher energy orbital? Means actually that thing will be known to us by reading or by observing, by studying Moeller diagram. So Moeller diagram states what? See, what is Moeller diagram? That means in atomic structure, the first cell contains S subcell, and also S subcell contains only one S orbital. You know this. Then second cell contains two subcells. Those are 2s, 2p. Then third cell contains 3s, 3p, 3d. Three subcells, SPD. Of course, the subcells again divided into orbitals, no doubt. Then fourth cell contains how many subcells? 4 subcells. What are those? 4s, 4p, 4d, 4f. Like that, fifth cell contains 5s, 5p, 5d, 5f, 5f, and another new orbitals are also there. What is that? 5z, 5z. But this is not necessary at your age standard. This is not necessary. After F subset, we have what is the G subset. Then like that, sixth subcell having 6s, 6p, 6d, 6f, and 6g, and 6x subcells. Okay, you try to remember up to SPDF, up to F only enough. Okay, and there are another subcells also there, new subcell. What is that? GF, GH, GH. Okay, Moeller is a scientist. He had given easy way to identify lower orbitals and higher orbitals. That means he given sequential order from lower orbital to higher orbital to fulfill the electrons. See, what is Moeller diagram is, you first you have to write like this, and you can strike two subcells like this. So here 1s to s. That means you can strike like this, and next you can strike two subcells, and you can strike next time 3. Okay, 3 subcells. Okay, here this arrow, this is front arrow, this is last arrow. Front arrow means the head, this is tail. So this head is connected to next tail. Again this head is connected to next tail, and again this head is connected to next tail. Head is connected to next tail. So by this what happens? You can easy to understand lower energy, order of lower energy to higher energy orbital. See, the first orbital is 1s. That means electrons are filling from lower energy to higher energy. That means electron goes into 1s orbital first, and followed by what is that? 2s, and followed by 2p. Next followed by 3s. Then followed by 3p. Here we are writing increasing energy of orbitals. 3s, 3p. Then 4s. After filling 4s, after completing 4s, then next electron enters into 3d. Then 4p. Then 5s. Okay, just at this 5s subset, you have to stop here. Okay, of course you go on continue after completing 5s. What is the next higher orbital? That means 5s is connected to this one. After 5s, what will come? 4d and 5p, 6s. Okay, have you understood this? You write down this. What is that? Energy orbitals from lower to higher. You write down this slide. So what this is called, what you remember? This is called Moeller diagram. Moeller diagram. Moeller diagram. Moeller diagram. It is nothing but half-bow principle. It is also called half-bow principle. Moeller diagram is called half-bow principle. Half-bow principle. Half-bow principle. It is nothing but, what is half-bow principle? It is building up. Building up. Half-bow means in German. Half-bow means, what is that meaning? Half-bow means build up. That means build up means you can arrange the electrons, or you can build up the electrons from lower energy orbitals to higher energy orbitals. That's why it is called half-bow principle, which will be easily understood from Moeller diagram. Actually, half-bow principle proposed by scientist Bohr. You remember this? Bohr. Scientist Bohr introduced half-bow principle. What is half-bow principle? Building principle. That means electrons are filling lower energy orbital first and followed by higher energy orbital. That lower and higher energy orbitals will be known very clearly by Moeller diagram. Okay, isn't it? Have you written this? I want to remove. Then today topic, what is that? We are going to write electronic configuration in different elements. The atomic range lies from 1 to 30. Today we will see one by one. So write down just like table. See element, 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 atomic number, atomic number. It is represented with letter Z. Already previously we studied this. Okay. Then you are writing electronic configuration. You write this table. Okay. You can take first element. What is this hydrogen? Hydrogen. So you know what is the symbol of hydrogen? H. Hydrogen symbol is H. Right now. What is atomic number? 1. Atomic number 1. So hydrogen symbol is H. Atomic number is 1. Isn't it? Okay. You want to write the electronic configuration of hydrogen, simply 1 is 1 because this is first one. No? First one. Atomic number 1 means how many electrons are present? Atomic number 1 means electrons are 1. That only one electron goes into lower orbital, that is 1s. That's why this configuration is 1s1. Did you understand this? Then second one, helium. Helium symbol is He. Helium symbol is He. Okay. Atomic number is 2. 2. The configuration is electronic configuration 1s2. Why you write 1s2, sir? Means each orbital accounted how many electrons? 2 electrons. 2 electrons. That's why 1s orbital is completed. That means S subcell contains one orbital that can accommodate 2 electrons. That's why its configuration should be 1s2. Hydrogen, helium. After helium, the next coming element is lithium. Lithium. Symbol is Li. Atomic number is 3. So if you want to write the lithium configuration, 1s2, 2s1. That's all. 1s2, 2s1. Why? Because atomic number is 3, no? That means electrons are 3. First 2 electrons are occupied s orbital of s subshell, and the left or last electron goes into next higher orbital. After 1s, what is higher orbital? 2s. That's why electron goes into 2s orbital. That becomes what? 2s1. Okay, is it clear? Then beryllium. Beryllium. So what is the symbol of beryllium? B. Beryllium symbol is B. Atomic number is 4. That means 4 electrons are present. So how to write configuration 1s2, 2s? One s to 2s. Okay, after beryllium, the next one is boron. Boron. The element is boron, symbol is B. Atomic number is 5. Then you want to write the electronic configuration 1s2, 2s2. 2s2 means here s orbital can accommodate only 2 electrons, it is completed. The next higher orbital is 2p. So see here, after completing 1s, coming orbital is 2s. After completing 2s, the next following orbital is 2p. Isn't it? Right. Okay. After boron, next element is carbon. Symbol is 6. Sorry, symbol is C. Atomic number is 6. That means 6 electrons are there. So you want to write the configuration of carbon like this: 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. Okay, Lucky, is it clear to you? Then after carbon, next element is nitrogen. Nitrogen symbol is N, atomic number is 7. Then configuration is 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. So in p subcell there are 3 p orbitals, p orbital, px, py, pz. Each orbital accommodate 2 electrons. So here 2p3. That means there are 3 more electrons can accommodated in p orbital of p subcells. Okay. Have you written this? I want to remove heading. Okay. Then after nitrogen, next element is oxygen. Oxygen symbol is O. You know this. Atomic number is 8. That means 8 electrons are present in oxygen atom. So what is its electronic configuration? 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. After oxygen, the coming element is chlorine. Chlorine symbol is F. You know, symbol is F. Atomic number is 9. Then what should be configuration? 1s2, 2s2, 2p5. After chlorine, the next coming element is neon. Neon symbol is Ne. Atomic number is 10. That means 10 electrons in present in neon atom. So configuration should be 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. So far we are writing electronic configuration up to atomic number 10, you know. Okay. Have you completed up to this? Then see, after neon, the next element is sodium. Sodium, that is Na. Sodium, Na. Symbol is Na. Atomic number is 11. Then configuration should be 1s2, 2s2, 2p6, 3s1. Why 3s1 is coming? That means 2p6 means p subcell contains 3 orbitals. Each orbital accommodate 2 electrons. That means 3 2s are 6 completed. You know. So whenever p subcell is completed, then third cell S subcell. This is nothing but S orbital is having more energy than this. That's why electron goes into 3s. Okay. Then magnesium. Magnesium symbol is Mg. Mg. Atomic number is 12. You want to write the configuration 1s2, 2s2, 2p6, 3s2. That's all. Okay. Then after magnesium, coming element is aluminium. You know symbol of aluminium Al. Atomic number is 13. That means 13 electrons are present in aluminium atom or element. So then configuration should be 1s2, 2s2, 2p6, then 3s2, 3p1. 3s2, 3p1. 3s2, 3p1. See here, students, you have to remember the last configuration. For example, from sodium, you try to observe from sodium what happens. This is the first cell over, second cell over, then electron goes into third cell. Third cell, that is subcell of third cell. So here the last cell it is called what? Third cell, you know, third cell. This is last cell, third cell. This is last cell. Last cell means third cell. Here third cell, last cell is called what? Valence cell, you know. Yesterday we discussed the last orbital, last cell is called what? Valence cell. So third cell is valence cell. This is called valence cell. Valence cell. Valence cell. So whatever the electrons present in valence shell, those are called valence electrons. Those are called valence electrons. Okay, valence electron. So the last configuration it is also called this configuration is called what? Valence electronic configuration. This is called valency electronic configuration. You remember this word? I will explain very clearly in coming classes. Valency electronic configuration. This is called valency electronic configuration. This word you have to remember. It will be understood very clearly in next classes. After aluminum, the next one is silicon. Silicon symbol is Si. Atomic number is 14. Atomic number is 14. Whenever you want to write the configuration, what happens? 1s2, 2s2, 2p6. Here what happens? 3s2, 3p2. So here 3s2, 3p2 is nothing but what? Valence cell. These are called what? Valence electrons. And this configuration is called valence electronic configuration. VEC. Valence electronic configuration. Valence electronic configuration. Valence electronic configuration. Okay. After silicon, what happens? Next element is phosphorus. You know this phosphorus. Phosphorus symbol is P. Atomic number is 15. What is this configuration? This configuration should be like this: 1s2, 2s2, 2p6. Here 3s2, 3p3. This is the configuration, total configuration of phosphorus. But the third cell is called what? Valence cell. Valence cell. Yes, this electronic configuration we have valence electronic configuration. VEC. Valence electronic configuration. Okay, is it clear? See, here I want to show what is the phosphorus atomic structure. This is nucleus, you know this. How many cells are there in phosphorus? This is first cell, you know. Second cell, you know. Third cell. So try to listen. Here 1s2. 1s2, how many electrons are present? 2. 2 minus. Here in second cell, how many electrons are present? 1, 2, 3, 4, 5, 6. Okay, 6, 7, and also with 8. Why? Because 6 plus 2, 8, no? 8. So in third cell, how many electrons are there? 3s2, 3p3. That means 2 and remaining 3. 1, 2, 3. Okay. So this is the electronic inner core structure of phosphorus. You have to draw this. It will help you to understand further atomic structure. Okay, just you can draw, and after you have to draw this. Okay, with this knowledge we can able to read some more concepts in atomic structure. Okay, Lucky. See, listen carefully. Try to say this. The last cell is called what? Valence cell. You know, this is called last cell is called. This cell is called valence cell. Yesterday in last class we discussed it. Okay. Before valence cell, this cell is called what? PS, penultimate cell, you know. And before penultimate cell, this is called what? No? APS, anti-penultimate cell. No? So last orbit, last cell is called valence cell. Before valence cell, penultimate cell. Before penultimate cell, what? Anti-penultimate cell. That means valence cell is called end cell. Penultimate cell is called n-1 cell. Anti-penultimate cell is called n-2 cell. For example, here end cell is third cell. End cell is third orbit of third cell. Then it becomes what? Penultimate cell becomes second cell. That's why it is second cell, Anti-penultimate cell becomes what? First cell. Because n-2 means 3 minus 2. In place of n, you substitute 3 minus 2. You are getting answer 1. That means APS is the first cell. Penultimate cell is the second cell. Valence cell is the third cell. Yesterday I told you, but have you remembered or not? I don't know. But yesterday I told you what is that? The electrons present in outer orbit or valence cell, those are called what? Valence electrons. And whatever the electrons present in penultimate cell and anti-penultimate cell, those electrons are called core electrons. Already I said, I told you. And yesterday I told you, no. So how many core electrons are there? 6 plus 2, 8 plus 2, 10 core electrons are there. How many valence electrons are there? 3 plus 2, 5. That means here valence electrons are 5. 5 electrons are valence electrons. These are called valence electrons. You know, here PS, APS contains how many electrons? 10 electrons. These are called what? Core electrons. These are called what? Core electrons. Okay. Today I conclude here. This session is closed here only. The remaining part will continue in next class. Okay. See you.
Wait.